Example 3. We are identifying linear functions using equations. Now, in order to see if a linear function is a linear equation, we need to first know what the linear equation is. The standard linear equation is slope-intercept form. If you don't know what slope-intercept form already is, slope-intercept form is y equals mx plus b. So if we have equations that can be put in that form, they are linear. If they cannot be put in that form, they are nonlinear. It's as simple as that. So here we have y equals 3.8. So there we have y equals mx plus b. In this situation, there's no x, but it's y equals 3.8. It's linear. And the reason this one is linear is because if we were to graph this, we would have zero slope because m and x represent our slope, right? In this situation, we would come up to 3.8 and we would draw our line across the straight line with no slope. So that's why that is linear. Over here, square root of x, we do not have a square root in our slope-intercept form. This is a non-linear function. C, 3 to the power of x. We have our y equals, is there a power of x in that equation? No. The only time this equation would be linear if it was 3 to the power of 1, because 3 to the power of 1 is 1, right? We'd have y equals 3. So, nonlinear. D, we have y equals 2 over x. Does not match, nonlinear. E, we have y equals 6 times x minus 1. Well, a way to tell if it's linear or not is we can distribute that 6. We have y equals 6 times x is 6x, right? 6 times a negative 1 is a negative 6. So, y equals 6x minus 6. It looks just like y equals mx plus b. The m is replaced by a 6. The b is replaced by a negative 6. So yes, it is linear. Okay, so we got the first row done. A, linear, B, nonlinear, C, nonlinear, D, nonlinear, E, linear. Now let's move on here. You might get an equation that looks like this. It's kind of hard to tell if it's linear or nonlinear, but typically when you see 1y and 1x, it's probably going to be linear. Now the way we can test to see if it's linear or not is we can put it into slope-intercept form. We can subtract our 2. That gives us 1 over 6. Y equals 3x plus 2. Now we can get this y by itself. Again, if you remember, if we want to get a fraction off of a variable, the easiest thing to do is multiply by the reciprocal. The reciprocal is the opposite of a fraction, 1 over 6. The opposite of 1 over 6 is 6 over 1, or 6. So we're going to multiply by 6 to both sides. Now when we multiply by 6, we have to multiply the 2 and the 3x by 6, right? Okay, so we canceled out that, so y is by itself. Let's distribute the 6. 6 times 3x, that's 18x. 6 times 2, that's 12. We have y equals 18x plus 2. Looks a whole lot like y equals mx plus b, right? So, number 19 is linear. Okay, we'll look at 22. Immediately, we see there's 9xy. Does not match y equals mx plus b, nonlinear. Okay, make sure you get all those copied down so that way you can understand. I'm going to move on. Okay, we look at f. It looks just like y equals mx plus b. This is linear. Okay, g. It kind of looks confusing, right? We see 3x over 5. Well, that's just the same as y equals 3 over 5x. So, it's linear. Okay, we look at h. We see an exponent, automatically we know that's nonlinear. We look at 20. We see y, x, x, y. The only way to tell if it's linear or nonlinear is try to put it in slope-intercept form. So let's try to get the y over here. Let's try to get the x over here. Remember the equal sign separates it, so let's add the x. And let's knock 2 birds out with 1 stone. Let's add our 2/3 y. let's worry about the x's first. First, let's bring our equal sign down. Our x's are canceled there. We just have y over here. 2x plus x, 3x. Okay, let's worry about our y now, which is in the red, right? Y, which is 1 plus 2/3 y, is either going to be 5 over 3y or 1 and 2/3 y. I want to put 5 over 3y. I think this is easier. Okay? Again, in order to get rid of a fraction on a variable, we can multiply by the reciprocal, which is 3 over 5. Let's multiply 3 by 3 over 5. Okay. These cancel. We have y equals. Now we can take 3 times 3, which is 9, and divide it by the bottom, which will be 9 over 5, or 1 4/5. So our x is now going to equal 9 over 5x. And again, that works because 3 is always over 1. Multiply straight across. 3 times 3 is 9. 1 times 5 is 5. This right here is a linear function. So this is linear. Okay, now let's look at 18. Let's check to see if it's linear or nonlinear. First, we'll bring our y down. We need to distribute that 4x. 4x times 8, 32x. Now, if you don't remember what x times x is, anytime we multiply two variables together, it becomes an exponent, right? So 4x times x is 4x squared. There's an exponent, which makes it non-linear. So, there you go. If you have any questions, please ask me in class. Try to work on this exit card. Fill the table to represent a linear function. So try to make these all the same to make that a linear function. The hint is going to be, if you go up by 3, you can get to 11. And it's going to still be a linear function.